The Windows operating system is one of the most widely used pieces of software in history. Windows was started before there were any alternatives to a monolithic codebase, because this was before the internet was widely used by consumers and by developers in their software engineering process. Networked computers gave rise to web applications, and that made software engineers begin to rethink how to build everything. After the web was widely used in software development got reimagined with Agile. Monolithic code bases got broken up into service-oriented architectures. Instead of going to a store to buy a box with software in it, users also were downloading software from the internet, and that software was regularly updated. Software that's regularly updated needs to be regularly tested. Instead of a single round of testing for every round of boxed software that was shipped to a store, continuous testing and delivery gradually became the norm. The process of releasing and operating software became its own set of engineering challenges, and this was tackled by the operations or sysadmin team at a software company. This made there be two different sets of engineers, those who were developing the software and those who were operating the software. The incentives of these two types of engineers were not completely aligned. The software developers wanted to build software quickly and release new features, and the operators wanted things to be released more slowly, because if something broke, the operators, the sysadmins, they were the first line of defense for fixing those problems. These problems between development and operations gave rise to the DevOps movement, in which developers and operations started working more closely together and sharing responsibilities. Incentives became more closely aligned, and new types of software was created to facilitate more harmonious relationships between developers and operations. For example, continuous delivery pipelines. Continuous delivery pipelines were a newer kind of software built around the time of a movement towards widespread DevOps. Today, most enterprises are still undergoing a transformation from monolithic software release cycles to continuous delivery. This is often referred to as a DevOps transformation. A DevOps transformation requires the entire organization to reorient itself around faster software release cycles. And this can be a painful process. We've covered it in many past shows in several different case studies. And hearing case studies from these different enterprises can be helpful for figuring out how to reorient your own enterprise. Microsoft is a useful case study in shifting towards DevOps. Windows is perhaps the biggest monolithic codebase in history, and the fact that Microsoft could re-architect Windows to be easier to work with should provide some reassurance to other enterprises that are currently undergoing their own migrations. Martin Woodward has been at Microsoft for 13 years, and he joins the show to talk about how software delivery within the company has evolved. We discussed the move from boxed software delivery to delivery via the cloud, and focused on a few specific long-standing products, such as Windows. Martin has been part of the effort to build Azure DevOps, which is a product that offers similar tools to the ones Microsoft built internally for DevOps as a service. We also talk about the specific difficulties that enterprises often have when moving towards DevOps. Full disclosure, Microsoft is a sponsor of Software Engineering Daily. DigitalOcean is a reliable, easy-to-use cloud provider. I've used DigitalOcean for years, whenever I want to get an application off the ground quickly. And I've always loved the focus on user experience, the great documentation, and the simple user interface. More and more people are finding out about DigitalOcean and realizing that DigitalOcean is perfect for their application workloads. This year, DigitalOcean is making that even easier with new node types. A $15 flexible droplet that can mix and match different configurations of CPU and RAM to get the perfect amount of resources for your application. There are also CPU-optimized droplets, perfect for highly active front-end servers or CI/CD workloads. And running on the cloud can get expensive, which is why DigitalOcean makes it easy to choose the right size instance. And the prices on standard instances have gone down too. You can check out all their new deals by going to do.co/sedaily. And as a bonus to our listeners, you will get $100 in credit to use over 60 days. That's a lot of money to experiment with. You can make $100 go pretty far on DigitalOcean. You can use the credit for hosting or infrastructure, and that includes load balancers, object storage. DigitalOcean Spaces is a great new product that provides object storage. And of course, computation. Get your free $100 credit at do.co/sedaily. And thanks to DigitalOcean for being a sponsor. The co-founder of DigitalOcean, Moisey Uretsky, was one of the first people I interviewed, and his interview was really inspirational for me. So I've always thought of DigitalOcean as a pretty inspirational company. So thank you, DigitalOcean. Martin Woodward, you are a principal group program manager at Microsoft. You're a vice president of the .NET Foundation. Welcome to Software Engineering Daily.
Hey, thanks for having me, Jeff.
You've been at Microsoft for 13 years, which is enough time to see a variety of evolutions of the company. When you started there, what was the release process for products? How did products make it from development out to the market?
Yeah, I joined Microsoft from a startup. We had a company with sort of 5 of my friends doing Eclipse tooling, believe it or not. And we figured, hey, that'd be a safe place to work that Microsoft won't want to buy us. But they came along and wanted to buy us anyway. So that was an early indication that times were changing, I think. I came from shipping to the web all the time. I was shipping into the Eclipse marketplace and, but doing instant updates kind of thing. And when I arrived at Microsoft, it was still very much, this is November 2009. It's very much still a shrink wrap culture. I'm a program manager, so sort of my job is to ship the right thing at the right time, and you kind of have to figure out what the right thing is and when the right time is, but it's a pretty easy job, ship the right thing at the right time. And so part of that involved being the box PM, so being the person, and that's literally what it was called, a box PM, so that kind of says everything you need to know for the product that Microsoft had acquired, that had brought into the company. So I had to go on a training course to learn how to, make it so I was able to sign off on the hologram that was used for the DVD that the software got burned onto, that was printed in Costa Rica and Dublin, and the boxes and all that sort of stuff, do all my ad law courses so I could approve the all the text that went on the side of the DVD cover. And when we were shipping software, you literally, called your release done. You put that into a system which took a couple of days to sort of move binaries from one place to another, and then landed in Costa Rica or Ireland, and they started manufacturing it, putting it onto DVDs, printing them and putting them into boxes, and then shipping those boxes to suppliers who then sold them. And that was very much the culture of the company, coming from that kind of mindset, which is kind of expensive to fix things, So you start operating in a mean time between failure is the thing you care about. Like, you don't want to ship, the thing you ship has to work, and because it's going to be printed on boxes and things. And if you have to have a recall that involves, shredding DVDs and things, then that gets pretty expensive pretty quickly. So it's a completely different mindset.
So the distribution format informed how the software development process went, and so it made sense to do a waterfall software development process, or would you call it waterfall?
Yeah, the most of the company was probably waterfall at that time. There were pockets of agile. Our team ran in an agile way, and so internally we were always potentially shippable. We would run a lot of dog food builds instantly and things, but having that mindset of a thing that gets released does lead you down naturally into a waterfall instincts if you don't sort of fight it. And it's more that it's the mean time between failures is the expensive thing. And so you have processes which optimize for not failing, rather than in a DevOps world and in, the modern world, you're optimizing for how mean time to fix, how quickly can you fix issues, rather than the mean time between failures. So it's a subtly different thing, but it leads to very different results.
When was the company able to focus its software development processes towards more of a cloud-based delivery model, and when did that cloud-based delivery model start to inform the development practices so they could move to a place where it was less of a waterfall, less of a shrink-wrapped development model?
So let me think. Obviously, Microsoft's a big company, and so different parts move at different speeds. I was over in sort of developer tools land, which kind of was pushing ahead here, and we were very closely affiliated with the Azure people and what was sort of the Windows Server people, and that became the Azure people. So they were obviously a lot more along that side. So this was around November 2009, and I'd come from a little startup. I wasn't sure. I had the deal you sign when you join a big company like Microsoft that kind of requires you to stick around for 2 years if you want to see any of the money. But I was kind of thinking, well, we'll see how it goes. I'm not sure how I'm going to cope joining this massive big company coming from cheeky little startup land. But it's been amazing in that I kind of joined at just the right time, because that was just as that transition was kind of kicking off. So my team was doing Agile, we were allowed to stay Agile, and then the rest of the group I was doing sort of, started, they'd had pilot kind of being a bit Agile, and then they went full on, we're going to change a whole sort of 500 people all go over from shipping in a more agile way. Interestingly, the key thing is that it wasn't sort of change, we become more cloud focused, which then means we can become more agile. It was, we saw we needed to be agile to be successful. So we changed our business and our business models to allow us to be more agile. So they kind of drove, one drives the other, which is interesting.
Well, this was 2009. So I guess that was right around the same time that the DevOps movement was getting started. Were you reading about DevOps then? Was that information starting to percolate to you?
So I was in the Git space and the Eclipse space. DevOps, not so much as a term. The term then was a lot around application lifecycle management and things. So I'd come from sort of Agile and TDD, and then the transition from Agile to more DevOps practices, I want to say probably happened for my group probably around 2014, because that's when we 2013, around about then, because that's when we started running a live service that needed to be up 24/7, and all those sorts of things, and we started to need to learn kind of practices for keeping an always running cloud service running, and that's kind of when I started digging into that space.
And I had trouble understanding what DevOps represented when I first started covering it, because I would just get these different definitions from different people, and it seemed like...
Depends what they're trying to sell often as well. But yeah.
Yeah, well, exactly. So it seemed to have something to do with Agile, it seemed to have something to do with continuous delivery, it seemed to have something to do with sets of tools. But over time, I think what I've come to understand is it was more like there were new tools, there were newer ways of delivering software, and those were informing a cultural shift. And then the cultural shift would also inform what new tools could be built, because there would be a change in culture, and then people would say, wow, we really would like to do things in some new way. If only we had a tool for doing that, and then the tool that gave a market opportunity for a tool to come into place, and then the tool would change behavior even more, and then you would have this back and forth, and it's really driven really rapid changes in developer productivity. And I imagine you probably saw this to an acute degree, because if you were coming from the Eclipse space, I imagine you had your eye on internal tooling. And I think of Eclipse as, that was certainly a development tool that I used a lot back in the day. Well, back in the day, as far as, don't go back very far, but the tooling has, Eclipse was like a cutting edge developer tool back then. Now there's like a bajillion developer tools you can have, and Eclipse was such a predominant one before. But maybe you could talk about how internal tooling, when you were at Microsoft, I mean, that's, you see the cutting edge of internal tools. How did the evolution of tooling inform the movement towards what some people were starting to call DevOps, maybe not in 2009, but 2010, 2011, whatever, whenever you start hearing about it.
So, yeah, regarding the DevOps thing first, we sort of, the way I think of it is the people process products is what we say, and that's in order of difficulty, but I'll carry on. And then it's the iterative continuous flow of value to your customers. So how do you get value into your customers' hands as quickly as possible and keep iterating on that? So, a continuous flow of value. And the DevOps movement is all about continual improvement, continually getting better. Nobody finishes their DevOps journey. Nobody suddenly is doing DevOps. DevOps is the journey to get, it is a journey to improve at getting this. And so if you're doing DevOps right, what you're doing is you're continuously looking about how to improve and how to improve those processes. And then that's what leads to what you were saying in terms of, you're constantly iterating and then you get faster and faster and faster because it's accelerating. So, and then it's definitely people process products because, the people are the hardest thing to change, and sort of, the wetware in there is always the sort of the stickiest bit. So you've got to be able to fix the sort of people. You've got to change the processes about how those people work, and then you've got to, provide products which support those people and those processes. And the products is kind of the easy part, and kind of, you can make do with current gen of products, and then you find yourself building new gens of products, and you can, you buy products off the shelf, you can use open source ones, you can do whatever, and assemble those together, which I guess is a weird thing to say for a guy that works in the space that sells these products, this tooling, but that's the easy part. But anyway, it kind of is, it's the people and the processes are the hard part. You just go buy or use, acquire some tooling from either open source or from from a company like Microsoft or something. And then so in terms of how we saw the change, again, it was one of these ones where it was iterative in itself. So we knew we needed to be fast. We knew we needed to ship quicker, because if you're trying to predict where the market's going to go in 3 years' time, which is what you have to do with box products because they're so expensive to print and then manufacture and ship. If you're shipping every 2 to 3 years, you're trying to predict where the market's going to be in 2 to 3 years' time. And you make of that prediction, you're gonna get it right 20% of the time and get it wrong 80% of the time, say at a roughly guess. If you're able to ship twice that speed, then you're going to, within the same period, within that same 2 to 3 years, you're going to have X amount more good features because you've seen what works and then you fix it and you move on, and you discard what doesn't. And so we very much saw that kind of thing was working. When I joined the company, it would be fair to say, and again, this is me coming from startup land and, not really a Microsoft person at the time, I was fairly horrified at the state of internal tooling. You would think that, you would think Microsoft would have the best internal tooling in the world, which hopefully it does now, and it's getting there, definitely, it's industry leading. When I joined, that wasn't the case. It was kind of like there's a saying in England and the UK, the cobbler's child has the worst shoes. So, the shoemaker's children have the worst shoes kind of thing. Because they hired a bunch of smart people to do smart things, they were busy working on products and kind of weren't working on the build and tooling that was building those products. And it was very fragmented into different groups inside Microsoft. So there was, you've got, say, like big teams like Windows and Office and, developer division, which is building all dev tools and people like that. Everybody would have their own build teams and their own tooling teams and their own reporting teams, and they all kind of work differently. And every area kind of had it very, very different ways of working, different sets of tools, different methodologies, different restraints. And if you were trying to move between areas inside the company, it was almost like just starting brand new in a new company. It was a completely different tooling set. So one of the things we've been doing is kind of driving a couple of metrics, kind of like improving, looking at the time it takes for a new hire into engineering. How long does it take for them to get code running in production? And then for a transfer for like somebody else in Microsoft, how long does it take for them to get up to speed and get code running in production? The goal for a new hire is 2 business days. That's where we want to get to. Bear in mind, when I started, it used to be 3 years because you would start on a team and then you would like hit the next ship cycle depending on up to 3 years sort of thing, 2 to 3 years, because you had to get some code in there and then it had to be built and then it would maybe get into a beta or something. But by the time it shipped, it could be 2 or 3 years between release cycles. Yeah, which is very different.
For all of the advances in data science and machine learning over the last few years, most teams are still stuck trying to deploy their machine learning models manually. That is tedious, it's resource intensive, and it often ends in various forms of failure. The Algorithmia AI layer deploys your models automatically in minutes, empowering data scientists and machine learning engineers to productionize their work with ease. Algorithmia's AI tooling optimizes hardware usage and GPU acceleration and works with all popular languages and frameworks. Deploy ML models the smart way and head to algorithmia.com to get started and upload your pre-trained models. If you use the code SWEDaily, they will give you 50,000 credits free, which is pretty sweet. That's code SWEDaily. The expert engineers at Algorithmia are always available to help your team successfully deploy your models to production with the AI layer tooling. And you can also listen to a couple episodes I've done with the CEO of Algorithmia if you want to hear more about their pretty sweet set of software platforms. Go to algorithmia.com and use the code SWEDaily to try it out. Or, of course, listen to those episodes. Now, I can imagine this is really hard to ordain from the top of the company how people are going to develop software because Microsoft's products span from the pre-internet era to the post-internet era. And so if you have a product like Windows or a product like Microsoft Word, you can't necessarily map continuous delivery to those products as easily as something that was born on the web, probably even something like Skype. So was there difficulty in establishing like consistent standards for the different teams when you have these radically different constraints around the testing process and the sensitivity of the infrastructure that you're building and just the delivery model of those different pieces of software?
The difficulties are mostly, again, we talk people, process, products. The difficulties are, first of all, with the people. Just getting them to understand, this is how we've always done it. These are the processes we always follow with these tools. Getting them to sort of sit back and think about, like, is this the best way of doing this? Do we need to change our business model to help us sell our products differently? When we first started shipping Windows, the way Windows was shipping was it would landed on your machine, And then when the internet came, we were able to sort of ship ISO images and things. But if you think about an ISO image, that's a very direct analog. It's literally a direct analog of the DVD, that they were physically shipping to before. And if you think about a modern internet-connected operating system, there's no reason why it all has to ship in one image. Why can't you ship enough to bootstrap and then download individual components, which is kind of how Windows is moving, and how it's moved in terms of there's a lot more store apps being there, there's a lot more things that get individually updated rather than just being part of the core OS. So yes, but it was difficult, mostly culturally. And I would say that the company is moving at different speeds there, depending on the products that they're servicing. So even within a group like the Office group, you've got the people who are building the Office web apps who are literally bleeding edge, JavaScript developers, like right there at the very front of how to build really deep, complicated web applications. and you've got the people who are building the client-side tooling that we all know and use, and then you have the work within the Office team to try and have not completely rewrite everything every time, to have a code base that's kind of shared, and how to do that. And those are long-term architectural things that take many, many, many releases to get there, and you kind of have to, you're making baby steps to get there because you're trying to do continuous flow of value to customers. You can't just stop and rewrite everything and throw all the old thing away. You've got to be making customers' lives better every single day.
Could we go a little deeper on maybe if you have some like a case studies, I don't know, Office or Windows or Minecraft or Bing, any teams that come to mind for how they shifted their development model?
Yeah. So, the one I know best is my team, which builds the Azure DevOps tooling, and how we kind of shifted from shipping an on-premises product called Team Foundation Server on a DVD, which people install client side, to then running in the cloud as a bunch of cloud services. And our transition sort of architecturally has gone very much is very much influenced by where we came from, but also we still ship the on-prem product and the cloud, versions from the same code base. So if we were cloud native, born in the cloud kind of thing, then we'd be using all the platform as a services from Azure and, from your cloud provider, because you get much greater density of compute there, and so you get much greater cost savings. And it's all about the amount of electricity you're burning at the end of the day, and how much of that you're turning into real work for your end customers. But because we have a product that ships on-prem as well as the cloud, the most dense unit of deployment we can kind of get to is probably containers. But we still have some services which aren't containerized and are running as VM images, in multiple sort of sharded VM images. So that's one transition, and then the kind of the thing we did there, and ours was very much an agile transition first, followed by moving to a cloud service, and then the sort of learning how to run a service and building that live site mentality. Customers are experiencing in the live site is what is all that matters. And when you're used to shipping box products, it's very easy to think about features and things like that, what's getting checked in. It doesn't matter what's checked in, it matters what experience that customer is having right now in the world. And building that mentality was probably the biggest shift for our team, because we had to learn how to run a service now rather than how to ship a product. There's other groups like Windows that do that less, so they've moved from shipping once every few years to shipping. They do ship multiple times per day in terms of the things like the signature updates and store and service updates. And then they sort of have a service Windows now have a servicing update every week. And then, you all know about sort of, like Patch Tuesday and things like that, and the Xbox updates that go out monthly. And then every sort of couple of times a year they do these big feature updates like Redstone 3 and things like this. And that's kind of the frequency was the big change from those teams. But from our team, we had to go the next full hog in DevOps and learn how to run a live site, which is a huge change. An interesting one that a lot of customers we speak to, they already know how to run live services because they're internal IT in a lot of companies and a lot of big enterprises and all that sort of stuff. They're used to running services. We really, really weren't. So that was a big culture change for us.
How did you do that cleanly? Because I've talked to a lot of companies that they've gone through some that's even more complex migration than many of the companies I've talked to, because you're going from this product that has to, you have constraints that you need to run on-prem as well as in the cloud, and you're building it for customers, and a lot of the companies I've talked to, they're just building like an internal application, like an insurance, like they're an insurance company, for example, and they're trying to move to the cloud, but they're not selling software to developers. You also want to keep your software in a place where it's at least comprehensible enough so that, as you said earlier, if I'm a new developer and I'm joining Microsoft and I'm working on Azure DevOps, then I need to be able to understand the stack, or at least the portion of it that I'm working on, in a couple days so that I can ship code very quickly. How do you do a migration like that where you want to keep the product accessible to the users that have been using it for a long time, while also updating it in a way that it makes it easier to ship in the cloud, for example?
Yeah, the classic DevOps way of finding the bit that hurts the most and then repeating that until it stops hurting as much, and then seeing what bit hurts the most next. It took us, where are we at now? It's, as we're recording this, it's the end of September 2018, so go out in October 2018 sometime. We started this journey, say, 2010, so we've been doing it 8 years, and we're a long way from done. So, continuously getting better. In terms of the stack, making the stack easier for engineers to understand, there were a few sort of epochs, if you like, that had to come in, a few sea change events. There's only so much you can do from continuous iterations. Occasionally you need like a big change. Moving a lot of our engineers over to Git as the version control system was a very deliberate decision to make it easier for new engineers coming to our stack to be able to know how to check in code and know how to do a pull request and all those sorts of things, And for a team like Windows, that was a ridiculously technically hard problem. They have, what's the last numbers? It's like over 500 gig of source in about 6,000 repos. But the big daddy is the Windows core repo, which is where, Windows as you know it, the thing that you look at and, if you're running a laptop or whatever, the operating system, that's a single repo that's got a 360 gig Git repository at the center of it, which is just nuts. And anyone that knows Git would tell you like trying to do that is just stupid. And remember, I got drafted in. I was like the first person on the ground when we were the Windows team were like, hey, we want to join forces and we want a single engineering system across the whole company and we want to base it on, top of a modern stack and we'd quite like to use Git. And I'm like, you are insane, Like, why would you ever think that that's a sensible idea? So there was a kind of movement as to, well, maybe we should modularize Windows. And I'm like, yes, that's exactly what you need to do if you want to use Git, because there's no way you're going to fit it in one repo. You're going to need to break up this legacy, I'm going to say legacy code, I shouldn't call it that. A code base that has, 25, 30 years of heritage, break that up and turn that, and then you can have manageable repo sizes. Turns out that's harder than just fixing Git and making Git work for really big repos, to have mono repos, in terms of a computer science problem. Because, these layers that, if you don't have the abstractions built in, if you don't have these interfaces and contracts built in, then trying to modularize things after the fact, trying to unpick that hairball of interdependencies is just too hard and too expensive and requires you to stop work, which is no good. You can't, you just have to keep shipping features to customers. So we went and we fixed Git, if you like. We modified Git to be able to scale up to that size. And then obviously with Git being Git, we then contribute those changes back to the community to make sure everybody else can also scale that big. Because regarding open source, it's no good us modifying an open source thing and taking it and then modifying it to make it work really big. If we didn't contribute those changes back to that upstream open source project, then the Git project itself, the open source Git project could diverge in a different route, and then we'd be left with our little orphan solution that's different that nobody else uses, and then we're back to how we were before, with now a fork of Git rather than in quotes real Git. And the whole point of using Git was to make it easy to bring people in from the outside, so and to make it easy for people to move between the company. So yeah, that interestingly, contributing the changes back to the open source Git project was a key requirement of why we were adopting Git in the first place. So, which is cool.
There was a show I did a while ago with somebody he was a Linux kernel maintainer, and he was talking about the fact that, for example, you can't use GitHub to manage Linux because the Linux kernel is too big. And I guess they also have specific collaboration constraints. So because collaboration for the way that Linux is built is so distinct, they have this strange email system that they use to collaborate with each other. But anyway, long story short, building an operating system is hard, and you have a lot of people, and collaborating on it is really difficult. But what were the changes that had to be made to Git in order to accommodate building Windows on Git?
Yeah, and you're right. Like the Linux codebase is sort of a 640 meg repo. And then the Azure DevOps codebase is a 3 gig repo, and then you get up to Windows Core, which is like 360 gig. So you're jumping up every time you go up an order of magnitude. Then you normally need like a complete re-architecture, re-platforming kind of thing. On that Linux thing, I know Linux has its own communication mechanism. Well, Linux does work fine in GitHub as a thing. It's the way that the Linux community sort of communicate their patches and emails and stuff. There's a certain amount of, again, I'm not directly in that community as a maintainer or anything, but there's a certain amount of, if you can figure out this process, then kind of you meet the bar to be able to contribute to the kernel, sort of self-selection thing going on there. It's, almost not deliberately not too easy to contribute, because then, the quality of contributions is higher. Whereas when we've got open source projects that have a really broad reach, being able to contribute to them is vitally important to us, which is what, why GitHub kind of won that space, because they invented the pull request, and they made that such an easy process for people to be able to contribute to open source projects now, and for maintainers to be able to maintain them, which is what led to a large part what led to their success, I think. So what did we need to do really to get to the Windows, get to be able to host Windows team? Git's a distributed version control system, which means that it doesn't require a central server. And in many ways, we kind of had to break that to get it to work. We kind of had to take the distributed nature out of it. What we did is virtualize the underlying Git repository, so that when you do a clone, when you get your source code down, you don't actually get the entire source code and all the history ever down, because that would be too big and would never fit. You wouldn't be able to buy an SSD big enough to fit that on. So never mind transfer it over network or make it work, So we had to do some changes to be able to virtualize that under the hood, and then put those changes into core Git itself to be able to support that kind of way of working. And that was a thing called GVFS. I think but then that was confusingly the same as the known virtual file system. So I think they've changed it now to like virtual file system VFS for Git or something. I should check what the open source name is. But that's an extension to Git, which kind of virtualizes the storage of the underpinnings. But when we did that allowed us to do some neat things, like we're taking to some extent the distributed nature out of a DVCS tool, which is a bit weird, but it still works the same way it works. It downloads the binaries on demand from a central server when it needs to rehydrate the objects. So a bit like, sort of how Dropbox and OneDrive and things like that kind of work with these virtual pointers. And then it also allows you to do some caching of those things locally in your local office. One of the differences between, say, the Linux project and the Windows team is the Linux kernel is maintained by a disparate group of individual contributors. There's some in pockets, like there's a pocket of them over in Red Hat, and there's a pocket who work actually in Microsoft as well. There's pockets of them, but mostly it's people who are individuals spread across the world. The Windows kernel is maintained by teams, and they're mostly in Redmond and a few other places around the world, and in specific buildings within those specific geographical areas. And it actually allows us to cache the copies of those files that they need local to them, and so you end up with an interesting thing where, even though the core Windows team are based in Redmond, and their Azure server, which serves their code base, because this is all stored in Azure DevOps, Azure repos, which is in Azure, but we deliberately picked the Azure data center closest to them to store their particular project, which is like West US or something. So
just to give more architectural color on what you're describing, so if I understand correctly, what you changed in Git to accommodate a giant product like Windows is this virtual file system. So if I'm a developer, normally I would have my entire code base on my local machine so that I can explore that code base as I want to, and I can click around in it, and I can understand the submodules and the sub-submodules and so on, and I can have lots of rich metadata in my development environment so that I can, introspect classes and things like that. And the problem with doing that in a gigantic repo is that you simply cannot fit all of the repo on your machine. And so you build a virtual file system, and the virtual file system indexes the metadata, or it has some metadata files that can tell you the relevant content of those files, so that if you actually open the file, only then will it be requested from the server on the fly, but it'll seem transparently like it's on your machine from the beginning, even though it is going over the network and pulling down the file, which can be really painful if you're somebody who's opening lots of different files and you haven't seen the files before. So you have to build probably like systems of caching. And of course, it's really important that if you want to cache the entire repo on some data center that's the closest geographically to, like you said, the team in Redmond,
the office,
and which illustrates this really interesting difference between Windows and Linux, where you could service those developers by just caching a piece of a version of the Microsoft Windows repo close to them, whereas Linux, people are all over the world, so caching a version of Linux close to everybody may be a bit more tricky.
Well, that's exactly what Git does. So there's a couple of, the actual problem is slightly harder than what you described is exactly correct. Apart from it's even a little bit harder because as a developer, when you do a Git clone of your repository from GitHub or Azure Repos or whatever, you're not just pulling down your current version of a code base, but you're pulling down every version ever of that code base. You're pulling down the full history. So again, for a team like Windows with 25 years of history, that's even worse, So, the Linux team, and you remember Linus Torvalds was, he wrote Git in a weekend is the story, didn't quite, but you know what I mean? He was fundamental in the creation of Git, and it works really well for designed for what the Linux kernel maintainers needed. And because they're individual contributors working distributed, remotely, they are caching an entire copy of the entire repository and all the history locally on their individual machines. And that's fundamentally how Git worked from day one. And that made sense for the Linux kernel maintainers because that's exactly how they work. That's not how the Windows team works, though, or large enterprise teams. There they have groups of people that are very, tightly geographically coordinated, co-located, sorry. We kind of tweaked the way it was stored to enable us to do that. It's a bit slightly clever in that we had to do some changes into Git as well, into how it crawled trees and things. And Git would break, because things were like, you would hit lots of n factorial problems and stuff. And so we had to change ways certain things were evaluated to support really large trees. And I can give you some links for show notes if you want that dig into some of like the real gory details. It was some fundamental changes to support, but fundamentally is because the teams work very, very differently. I mean, even things like branches, normally Git would breaks if you have more than say a couple of thousand branches. And you think, well, who would need a couple of thousand branches? Well, the Windows team, I can just go look it up now. The Windows team has got 7,500 developers, there you go, who are coding on those repos. Each person's, doing, and they do chunk-based development mostly. So if you're doing a feature branch and then merging it into master, you've got at least 7,305, 7,500 branches already. And that's just one developer's working on one thing and then deleting and remembering to delete their branch instantly. And that's not even having any teams of developers working together before they then merge their thing in. So we had to build some stuff into the server, into Azure Repos to kind of hide branches by default. So when you clone from Azure Repo, like this is server-side magic we ended up putting into Azure Repos. So when you clone for WDG code, the Windows code base down, you only get the branches you care about, i.e. branches you've created or your team are working on, if you know what I mean. You don't get everybody's branches. So there's a few little neat hacks like that we had to do as well. While I'm here in the number, I'm just looking at a dashboard here. If you have 7,500 people, In the most recent update of Windows, there were 4 million commits. So 4 million changes happened to that Windows code base in the single, 6-monthly update. So, which is crazy, isn't it, really? And there were just the build time alone for that update was 1,200 machine years of build time to build all the incremental builds that happened. So doing software at scale is just nuts. It really is. It's quite mind blowing when you start digging into it. It's amazing it all works, isn't it?
It sure is. I have immense gratitude for that. So this is an extreme example that we're talking about, but it's basically it does illustrate the lengths to which developers are willing to go to get a better development process. And the DevOps movement is all about that. It's all about, as you said, people, process, and products. Yeah, so it's worth doing this load of work because otherwise you're not going to be nearly as productive as if you make that painful shift. And this is what companies all over the world are realizing, and at the same time they're moving to the cloud, and they're also there's companies like insurance companies that are going from being an insurance company to being a software company, and that shift is difficult. So there are all these difficult shifts that are happening, and if you're on the Azure DevOps team, then you're in a perfect place to see the tooling that needs to be developed to allow these people to work more fluidly. So what does an average enterprise that is making this kind of shift? The average enterprise is not changing Git to accommodate Windows.
No,
so that
nor should you. If you do, then you're clearly crazy. You know what I mean?
Right. They're talking about breaking up their monolith at the insurance company and getting it into the cloud, and which is its own set of really difficult challenges, but you can solve those in a much more generalized fashion than fixing Git for the Windows team. So what kinds of tooling does that kind of enterprise need?
So the key thing I always try and emphasize when I'm talking with customers who do real jobs rather than the stuff I have to do is people get hung up on, oh no, I have to completely refactor my entire code base to Kubernetes or whatever, the latest hotness in developer trends. And then by the time they've completed that migration, there's another hotness to migrate to. Or I need to move everybody over. I need to have trained everybody in Agile. They think of it in big bangs. Don't. The whole point of DevOps is to just be continuously improving. So what is the most pain? What is causing you the most pain right now? What's slowing you down the most in terms of delivering value into customers' hands? And I'll be honest, when I'm talking to a lot of enterprises, mostly now people have kind of got they've got source control kind of under control, which when we first started, when I'm old enough to remember, when source control was just zip files backed up, and even for a large team working on the mainframe, you often didn't have source control. You were just using sort of data sets in a certain file structure. That's how old I am, So we've mostly solved that problem now. We've mostly, through the 2000s, figured out continuous integration and unit testing to a certain extent, so we can be continuously integrating and not constantly having to fight the merge debt, the merge pain, which was slowing teams down. So we've mostly got continuous integration kind of figured out, or people are frightened of it and they don't like to touch it because it's scary and might break, but it kind of works. The next stage is often around deployment, being able to automate how you get your bits from check-in to actually the thing that needs to ship into the customer's hands. And then the next level of pain is getting the things into the customer's hands. So this continuous deployment, continuous delivery is where I'm seeing a lot of people is their primary pain point in terms of improving the flow of value. And again, you listen to people like us and chatting away and talking about these massive web scale services and delivering to cloud and blah blah blah, and great, that's awesome, and you can kind of see how that can be done in a continuous delivery model because you're delivering to one point. But I go back to my Eclipse days where I was doing Eclipse updates and, talking to a lot of people who were doing, still doing Windows desktop apps or, line of business applications and things like that aren't even shipping to a website. How do they do DevOps? And can they do DevOps? And the answer is they definitely can, but they need to make some architectural investments to make it really easy to install for their end users to pick up the latest version of their bits and get it running on their machine. So look at store applications or look at things like Squirrel, which is the sort of installer technology that's used behind VS Code or Slack and all those sorts of things. So continuous delivery and technologies. And so that is things like, continuous build and release. So Azure Pipelines is our product to help you with that space. But then there's things like Jenkins and Travis and people like that, in terms of doing this continuous integration, continuous build, continuous deployment pipelines. And then you've got your how do I get my thing from there into my customer's hands. So often it's installing it onto a web server. Great. How am I going to make sure I can install it onto a web server with zero downtime and those architectural problems? Or how do I get it installed into the customer's hands? How do I publish into the App Store quickly? How do I get it, their desktop application updating? So they're the kind of spaces to invest in.
This episode of Software Engineering Daily is sponsored by Datadog. Datadog integrates seamlessly with container technologies like Docker and Kubernetes, so you can monitor your entire container cluster in real time. See across all of your servers, containers, apps, and services in one place with powerful visualizations, sophisticated alerting, distributed tracing, and APM. And now, Datadog has application performance monitoring for Java. Start monitoring your microservices today with a free trial. And as a bonus, Datadog will send you a free t-shirt. You can get both of those things by going to softwareengineeringdaily.com/Datadog. That's softwareengineeringdaily.com/Datadog. Thank you, Datadog. So I go to these conferences, and when I'm at the conferences, I always walk around the expo hall because one thing I like about the expo hall is you see the interaction between developers and the products that they're purchasing and also the things that they're not purchasing. And you get a sense for how the tastes of developers are evolving. And what I've seen there's conferences like Velocity or the DevOps Enterprise Summit where DevOps is a big focus. There are all these vendors for things like code hosting and project management boards and dashboards. And then there's the actual deployment systems, and then there's monitoring, and there's all these different things. And then some of the vendors have bundles of them together. You can get a variety of things all in one.
We would be in that category kind of thing, and
right. Yeah. And so it makes for an interesting build versus buy set of decisions because you can build an integrated provider. You can buy an integrated provider. You can stitch together open source tools together with random vendors. You can piece together entirely different vendors into one thing. How does a developer make these kinds of purchasing decisions, or a CIO or a CSO? How do they figure out how much integration they want between these different systems, and where should the integration points be? Since you were heavily involved in the product architecture for Azure DevOps, you must have thought about the purchasing process that this kind of developer wants to go through.
Yeah, and there's always a difference between the purchasing process that the developer wants to go through and the one that the CIO wants to kind of mandate and things, which is always fun. The key thing is you need to make some bets on sort of technology trends, but equally you want to be able to hedge your bets. So for instance, moving your team to Git to just Git itself is a great bet, because now you have lots of vendor choices, and now you're going to have them all competing with you for the best Git hosting experience. and you know that there's going to be lots of innovation there. So, yay. And those are the sorts of things you want to be doing, in identifying these key areas where I can make a bet on a technology. And you can tell I'm not a salesperson, can't you, Jeff? But anyway, I'm avoiding sort of vendor lock-in. I'm giving myself the most choices and the most flexibility. So, you do that and then you've got lots of vendors. Like, the same's happening with sort of Docker to a certain extent, in that everyone's sort of standardized on the Docker, the Docker kind of file format, the Docker container format, but then, and moving towards now sort of Kubernetes is a way of managing the swarm of Docker containers, but there's still plenty of competition in that space as well, and you're not getting vendor lock-in. If you have a Docker container, you can move it to any cloud-hosted provider and on-prem very, very, very easily, So yeah, that's the way I make it. And that's kind of fed in how we've changed the product recently, because we've moved from, in the old days, it was very much a sort of suite of software that was built. It was kind of purchased and mandated from the top, thou shalt use. And so that's why sort of we had the suite of like a suite vet product from a company like Microsoft. Here's a turnkey solution, buy this and all your problems are solved. 5,000 people in your company can use it tomorrow and it's all good. And moving much more to a model that's buy the capabilities you want, which is how a cloud is if you think about it. Like, development environments naturally reflect the thing that you're developing for. When we were building desktop applications and client applications, then you have the big IDEs like the Eclipses and the Visual Studios and like the things before that. They naturally reflected the thing you were building. In the cloud, you need a much more distributed, heterogeneous model that needs to be spread and needs to be a lot more pluggable. And that's kind of like that's cloud native, because that's the thing that you're building for is like that. And so the way you build it is also like that. And so we've very deliberately kind of broken out our product into core bits of functionality that are very, very open and pluggable with other things. So it works great if you want to buy it all from us. Awesome, great. And we'll make that super easy and super cheap for people. If you want to use our pipelines product, if you want to use Azure Pipelines to deploy to take code from Bitbucket and deploy it to AWS, then we should work just as well for you there, which is what we've deliberately gone and done. So we have the integrations on both ends, and we work with Amazon for them to build the things that deploy bits to AWS, and so yes, we have an awesome experience for deploying to Azure, but we also have to have an awesome experience for deploying to AWS and GCP, because that's how people buy these tools. They're not going to buy something if it gives them vendor lock-in. So we deliberately build tools that are giving you lots of choices and trying to use open source and industry standard, kind of ways of interchange as much as possible there.
So you're describing this, like the DevOps experience that you want to have is very much like the experience you want to have in a cloud provider. So like in a cloud provider, you log in and there's like 5,000 different services that the cloud provider offers, and then you can go into the marketplace and find a bunch of more services that are offered by a variety of other vendors. Like if you're on Azure, you can find like Cloudera. You can easily install Cloudera using the marketplace, and then but you're saying that for DevOps, you kind of want the same thing. You want this buffet of options that you can integrate with easily, and it's kind of a marketplace kind of experience. But you also have centralized, like a standard, opinionated ways of doing things that are in accordance with how Microsoft sees DevOps.
I think that's what most customers want. That certainly seems to be from when I talk to them. They don't want to be locked in, but equally they find all the choice quite overwhelming, and they'd quite like some opinionated guidance as to what they should go down, And, even with the cloud providers, like you're looking, say you want to, you go and you're doing your just basic stuff like the CDN, you can go into Azure and get the Azure CDN, or you can go to Azure and buy Akamai or buy, one of the other CDNs, or you can go to AWS and buy their CDN that's CDNing stuff that's stored in Azure. It's all there, and it should be interchangeable and plug and play. So you can, because the whole point is you want to iterate. You don't want to be throwing stuff away. You want to be iterating rapidly, and you want to solve the thing that's most painful for you right now. And if what's not painful for you, don't want to have to change things which are working just great for you, you know? So leave them alone until they become the thing that's slowing you down the next time, and just keep incrementally improving, keep incrementally adopting. And you find that these massive improvements, like we were talking about Microsoft's delivery at the start of the show, and it was like every 2 or 3 years kind of thing is when stuff got shipped. We ship 78,000 times a day now. Like there's 78,000 deployments a day come out of Azure pipelines in Microsoft, because that's what we use for Microsoft alone. And that's just madness. But that took us 10 years to get here. And like the first time we improved, we shipped every 6 months rather than every 3 years, And then we shipped every 6 weeks, then every 3 weeks, and now multiple times per day. So just slowly make those incremental improvements. Don't feel like it's completely, oh no, I have to rebuild everything and start from scratch. What's the thing that's causing you most pain right now? Improve that, repeat, is my advice.
Just to wrap up, that's a great piece of advice, but do you have any other pieces of advice that, since you're talking to a lot of different customers, I mean, the thing that I always hear from enterprises that they're having a lot of trouble with is testing around their big ball of mud monolith, for example. So like that is a huge inhibitor to getting to continuous delivery, because if you can't test the big ball of mud, then you can't really continuously release it, and that just becomes a big bottleneck. That's not really any advice I can give, but it's just some commonality I've discovered talking to different enterprises. But what advice would you give to these enterprises who are adopting DevOps?
Yeah, get started in a little bit is what is the main thing. But you talked about testing there. That's a really interesting one, because especially with, like, again, when I had a real job, you're trying to get the business to stop doing business for a day and come and test something and then go back to doing the business again. And that's always a hard sell, because they're busy doing business and making the money that pays your wages. So making the architectural changes possible so that you can do things like progressive exposure. You can rapidly fix what's running in production and move towards testing in production. That's why the people who are doing more testing in production we're finding them being more successful. That's not to say disable testing and just go like deploy everything to production tomorrow, because you'll deploy some horrible mistakes. You need to get there slowly and like incrementally and get there. But being able to expose a proportion of your user base to a new thing first is a great baby step. Being able to compare, for a proportion of your users, the traffic of the old code, like what results I would have got from the old code, which is what you give the end users who are in production. Compare that programmatically with the data that would have come from your new code and see if they get the same answers. But if you start investing in those kind of practices and that kind of infrastructure, then that allows you to iterate more quickly. That's why investing in unit tests was worthwhile, because it allowed you to do continuous integration, which allowed you to iterate more quickly and have confidence in doing big, when you do big code refactoring. But if you haven't got the unit tests, then you're scared of refactoring. So how do you address that? And maybe being able to test code in production or test code, using production traffic is a great way forward for you. Continuous deployment, continuous integration, getting things into your customers' hands as quickly as possible. And then how quickly can you ramp up your engineers? When I bring a new engineer into my company, how long does it take them to have code running in customers' hands? And focus on how happy are my engineers? The more frequently engineers ship, the happier they are. That's proven in the data from the latest Stack Overflow survey. So, how happy are your engineers? How happy are your customers? How quickly can you get stuff into customers' hands?
Martin Woodward, it's been great talking to you. Thanks for coming on Software Engineering Daily.
Thank you very much. Good to speak to you.
We are running an experiment to find out if Software Engineering Daily listeners are above average engineers. At triplebyte.com/sedaily, you can take a quiz to help us gather data. I took the quiz and it covered a wide range of topics: general programming ability, a little security, a little system design. It was a nice short test to measure how my practical engineering skills have changed since I started this podcast. I will admit that though I've gotten better at talking about software engineering, I have definitely gotten worse at actually writing code and doing software engineering myself. But if you want to take that quiz yourself, you can help us gather data and take that quiz at triplebyte.com/sedaily. We have been running this experiment for a few weeks, and I'm happy to report that Software Engineering Daily listeners are absolutely crushing it so far. TripleByte has told me that everyone who has taken the test, on average, is 3 times more likely to be in their top bracket of quiz scores. And if you're looking for a job, TripleByte is a great place to start your search. It fast-tracks you at hundreds of top tech companies. TripleByte takes engineers seriously and does not waste their time, which is what I try to do with Software Engineering Daily myself. And I recommend checking out triplebyte.com/sedaily. That's triplebyte.com/sedaily. TripleByte, byte as in 8 bits. Thanks to TripleByte for being a sponsor of Software Engineering Daily. We appreciate it.
Wow.